Aloha and welcome to our video on soil. The goals for the video are to recognize the major components of soil, to list the most important factors in soil formation, explain how soil varies with depths, we'll compare and contrast the three common types of soil, and finally we'll demonstrate how human activities affect the rate of soil erosion. So when we're looking at the composition of soil, we're going to take an example here of some good quality soil here. We'll notice that the largest component is 45% here. It's going to be mineral matter. So this is going to be broken down rocks primarily into small enough pieces that it's like clays and silts and sands, things of that nature. So very small sediments. Now we also have 5% organic matter, and this is primarily going to be the decaying and decomposing remains of primarily plants, but also some animals. We also have some microorganisms that are going to play an important role in soil as well. We also need to have water, so it's going to be about 25% water that way. And then we have this 25% air, and this is going to be the holes, the porosity of the soil. So when we get our small little bits of the mineral matter that are all going to line up like this, then we add our little biological components. We'll add a little bit of water in through here, but we still end up with these spaces, and these spaces are going to be about 25%, and this is going to be that air that's going to flow through there. So we'll talk about how all of these different pieces and parts are important for that soil and are necessary for it to be considered fertile and good for plants. And the lesson will go into this in a lot more detail. So now when we talk about texture of soil, what we're talking about primarily is what it's made up of, what kind of things we're seeing in there, what size are the mineral deposits. So we can talk about being whether it's clay sized or sand sized or silt sized. And then where it falls into this is about where we start to find out what it is. So if it's primarily clay, we'll call it a clay soil. If it's primarily sand, it'll be a sandy soil, so a sandy loam or a sandy clay. And then if it's going to be silt is where we get our our clay loams and our silty loams and things of that nature. So you can see by the size of the particles inside is how we determine its texture. And this kind of graph shows you a little bit, and the lessons will go into it a little bit more. Okay, so let's talk a little bit about soil formation. When we're talking about soil formation, there's a bunch of different things that factor into it. The first one is going to be parent material. And if we look over here in this drawing, what we see is we have the bedrock, which is the original rock, undisturbed rock layer. Now that'll get broken down through weathering, and if it stays still, then we end up with residual soil. That's soil that's going to be broken down and the sediments just kind of stay right there. If the sediments are transported, then we end up with transported soil. And that's going to be where it's moved down by a river through erosional processes, and it's no longer where it broke down from the bedrock, but it's been moved from one place to another. Now the next component is time, and it does take a lot of time for soil to form because you're not talking about a rock that's going to magically, boom, turn into soil overnight. The rock needs to be broken down. You have to have some pioneer species move in, and then they have to die off, and you have to get that biological decaying stuff there. So it takes a long time for soil to form. Now, this time can be affected by things like climate and by organisms. So if there's a warm, moist climate where you get a lot more weathering occurring and you get a lot more plant growth and decay, then you'll see the soil form a little bit quicker. If it's a dry climate like a desert, it can take a long time to make just a little bit of soil. The organisms are primarily microorganisms, and those will be like bacteria and stuff, which play an important role in the nitrogen cycle, which you can see down here. We have a lot of nitrogen in the air, but plants and animals can't use that, so we have bacteria that will fix that into plant's usable form, and then we can get it that way. And then finally, slope. If you look at a mountain, if we have a nice long gradual slope like this, it's going to stick around more. You'll probably get some more soils and it'll form deeper here. Versus if it's a real steep slope, then there's not a lot of places for the soil to accumulate, and you end up with a very thin or almost no soil at all. Now if we take a cross section of the soil, so we're going to take a look down this way, we can break it up into a bunch of different regions, and primarily we're going to go through 4 of those. So the very top layer is the A horizon, and that's called your topsoil, and this is where we see our primary soil that we're used to. It's loose, it's partly decayed organic matter, there's mineral matter mixed in with some organic matter. This is topsoil, this is the dirt that we're familiar with. If we go down to the B horizon, then what we notice is we have some clay that's transported from above. So what that means is the clay and stuff is going to settle down into the B horizon here. In the C horizon down here, so we have the A, B, and the C horizon here, that's where we're going to have this just partially weathered parent material. And that's going to be down here. This is our unweathered, our parent material. We'll call it a P here. This is our bedrock. This is breaking up. So here we have just simply our bedrock is down here. Here we're going to have broken up. So we're going to have weathered rock is all. Okay. The next layer, the B horizon, is primarily going to be clay. And that's about as deep down as the roots are going to go. And then we end up with our soil here, our dirt, let's call it. And that's going to be our A horizon. So you can see the different parts here. In the lessons, they'll go into them in a lot more detail. I just kind of wanted to give you a quick overview real fast. Okay, so let's take a quick look at our three basic soil types. We have the petal fir, the petal cal, and the laterite. The petal fir gets its name. Petal means soil, and there's a lot of aluminum and iron inside of there. So because we have these iron oxide and aluminum oxides, what we're noticing is we get a rich brownish, kind of browny red color in soil. And this is what we find primarily in the east in the woodlands, in the forests and such. Now we also have the petal cal. Petal cal is high in calcium and aluminum. That's why it's called petal cal. And it has this aluminum that you can see in this calcium that you're going to see over here. And it's going to be a lighter colored brown, almost a grayish colored soil. And then finally we have the laterite, which is from the tropics. And that one's going to be a really noticeable red soil. And the reason for that is it has this iron oxides in it and the iron-rich clay, and that kind of gives it that reddish color. Now, one thing to notice with the laterite is it doesn't have very much humus because the organic material decomposes so quickly in these tropical areas. So you don't get a lot of buildup like you'll see over here in our petal fir. So these are our three basic types. The lesson will go into them in a lot more detail. I just wanted you to get a quick look at them. Now, humans play a major role in soil erosion. What we've done is we have some not great practices when we're building stuff and things like that. We cut down all the forests, and then rains come through and we take out the roots, and that allows the soil to transport away. So we have a big issue with that one. When we allow that to happen, then we end up with sediment deposition, which is where it falls out of the rivers, and we'll talk about that a little bit more in the next couple of units. But we do have ways of controlling erosion. What we can do is if we have our land here and the wind's blowing, we can put up windbreaks, and primarily it's going to be pine trees because they grow kind of fast, and that'll stop wind erosion from occurring. We kind of knock the wind down where it's close to the ground so it doesn't have the ability to blow away the dirt. We can also terrace, so if we're going up a mountainside, we'll kind of level it like this, and we'll kind of grow it in these terraces, and that way we have plants growing here. What we're actually causing is the water goes down, it'll fill, and then it's a slower trickle down. So if you see the water, instead of it just whooshing down and taking away all the soil, it kind of pools here for a little bit and then drips over and drips over. So it's a slower pathway for it to go down, and that'll kind of save the soil a little bit there as well. And then finally, we'll rotate crops around. And that works really well because we can put in crops that'll replenish soil nutrients, and then we'll use ones that'll use those up and then go back and replenish. And that's what we're talking about. So that's it for our video on soil. Like I said, it was just a real quick introduction. The lesson will give you more. As always, good luck on the lesson, and we'll see you in the next video.